Okay, in this section we'll be looking at algebra, so talking about algebra, and evaluating algebraic expressions, and we'll also look at translating worded phrases into algebraic expressions. First off, just a question maybe for you to think about is what is algebra and why do you love it? Or what are some things about algebra that you don't like? Typically, people that say, "Oh, algebra, oh no, it's all dealing with x's and y's and fighting with those things." And true, x's and y's are things that we use in algebra. And I guess the trick with those is looking for rules or guidelines that you can use in order to deal with the x's and y's. If you become good at the rules and the guidelines, then the x's and y's actually turn into be a strength and to something that you might, I don't know what love, but that you get familiar with and that you won't mind them that much. Okay, so the power of algebra actually lies in those x's and y's, or the ability to use a similar expression for multiple different applications. So algebra uses letters and numbers, constants sometimes, and operations to express some kind of relationship. For example, this relationship you've all probably seen before, length times width, and it refers to the area of a rectangle. So to find the area, all you have to do is figure out what the length is, figure out what the y is, or the width is, multiply the two, and you come up with the area. I could have used an X and a Y or any other kind of letter there that I wanted to. But that's a powerful thing. If I have a room that's 10 by 30, I know I just have to multiply the length, that might be the width this time, by the width, and it'll come out to, and it'll tell me what the area of that room is. That's a powerful thing. That's a simple algebraic expression, but it is one of them. And there's tons and tons of them. When we're substituting, like I did there, and I just did it quick with length and width, but let me show you another time where you can substitute in numbers in an expression. So it says evaluate this algebraic expression, a plus b, when a is 38 and b is 27. So I guess they're indicating that a could be another number or b could be something else. In this case, they want these two in there. Now, whenever I do any kind of substituting in, what I like to do is where the a is, I put a bracket in. Plus, where the b is, I put another bracket. And then I substitute what a is. A is a 38 and b is a 27. In this particular case, it was probably easier just to write in the numbers and add them together. That's probably easier. But you find that putting brackets in will help you immensely, especially when you get into integral numbers, and it'll lessen the number of mistakes that you make. Here's another one. I have a couple of pages of these. Feel free to pause and try them on your own, and then come back and see if you're on the right track. Evaluate 5 times p when p is 21. So 5 times whatever p is, in this case 21. Multiply those two numbers, and so 105 is the answer to 5p when p is 21. Here's another one. X minus y when x is that, y is that. So x is 63 minus y is 29. So it's almost 30, so it'd be about 34. So 34 would be the value of x minus y when x is 63 and y is 29. A couple more. Oh, evaluate 9p divided by q when p is 20, q is 15. Okay, so 9 times something for p divided by q. Okay, p is 20, I put that there, and q is 15, I put that there. So now I can just go 9 times 20, 180, 180 divided by 15, yeah, I don't know, it's 1, 2, 12 times. So the value of this expression when p is 20 and q is 15 is 12. Here's another application, distance, rate, and time. Find the distance traveled if you ride a bike for 3 hours at 30 kilometers an hour. So here's our formula. Distance equals speed or velocity or rate times time. So my s would be, that's the speed, would be 30 kilometers per hour, multiplied by the time, which is 3 hours. Notice in this case here, we don't often do it with letters, but I like to, but my hours both cancel. So I'm winding up going 30 times 3, so that'll be 90, and the unit that's left is kilometers. Okay, so evaluating this expression here, if the rate is 30, the time is 3, I would go 90 kilometers. Now sometimes you're given questions, I guess similar to this one, where you may not know exactly how you write the relationship. Here I had 9 times p divided q. Here I didn't tell you the relationship, but I wrote it. But sometimes you might have to read it in from a question. And oftentimes those get a little bit tricky. Here's just a quick guideline. If you see words like add, or sum, or total, all of those things basically say, hey, you're going to be adding something. For subtracting, here's some words. Multiply, here's some words. That might be a key one. Often with multiply of means multiply. Not always, but often. And divide. So if a question says, what is a half of 48? I see a keyword of. So all I'm going to have to do on this question is going 1/2 of means times 48. So half of 48, if you multiply those two, they come out to 24. Let's try a couple more. And let's look for those keywords. Less than, more than, 6 more than 8 times a number. The difference, 43% of a number. 300 less than the product, that's times. Less than, subtract. This would be a times. The difference, subtract. More, add, times, that would be multiply. More than, that would be add. Less than, that has to be subtract. So let's go through and see if we can actually write expressions for each one of these. So 5 less than a number. Would that be 5 take away a number, let's call it p? Would that be 5 take away p? So 5 less than a number. So say my number is 40, and I want to know what is 5 less than 40. My answer to that would be 35, right? Would that work in this case here? 5 take away 40. If I subtract that, that's going to give me a negative number. So this expression here is probably wrong. 5 less than a number. So if I have a number and I subtract 5 from it, that's going to be a better expression of this worded phrase here. I guess I could use P. The letter doesn't matter. 12 more than a number. 12 more than would be add. A number, let's use Q. 12 more than a number. Would that be the same as if I rewrote those backwards the other way? Would be the same. And that's, I think, called the commutative property. But the order of those doesn't matter. 6 more than, 6 more, add, so 6 plus 8 times a number. So 8 times a number. Let's use x. So 6 plus 8x. Notice that's perfect for this one. But you could also write it like this. If you're adding, again, that's a commutative property, the order doesn't matter. Notice up here when we're subtracting, the order of the numbers do matter in subtracting, so I can't just swap those. The difference of two numbers. Okay, let's make our numbers, I don't know, j and r. So the difference of those two, j minus r. 43% of a number. 43%, I can write 43% of means times a number. Let's use n. So that would be an expression of that represents this. Now 43%, often we convert percents to decimals, so probably another way of writing that is 0.43 times n, or 0.43 n. Okay, and the last one, 300, oh, there's one of those less than's. I have to worry about the order. 300 less than the product of two numbers. So the product of two numbers, let's call them x and y. So x times y, and 300 less than that. So x times y minus 300. Okay, or is it 300 minus x times y? Let's just pick some numbers and throw them in. So let's say the two numbers, why don't we go 20 times 30. So say those are my two numbers. So 300 less than 20 times 30, maybe we should use another number. Now those will work. 300 less than 20 times 30. Well, 20 times 30 is 600. So 300 less than 600 would be 300. So 300 is my answer for this question. So let's see if these work out. So x times y, so 20 times 30 is 600. 600 minus 300, sure enough, that gives me the correct answer. Let's see why it doesn't work in this one. 300 take away x is 20 times 30. So 20 times 30 again is 600. And 300 take away 600, that'll be a negative 300, which isn't what I had up here, so it can't be this one. So really the only trickery ones with these are the ones where they say less than. So if they say less than, 5 less than a number, you've got to make sure that you maybe check it. Typically what you do, if it says 5 is less than a number, say the number, take away 5. Or when they say 300 less than the product of numbers, find the product less than whatever number they have there. Hopefully that gives you a nice, just quick introduction to evaluating algebraic expressions with numbers, and also using words to come up with some kind of an expression. Practice a bunch of those in your textbook.